Assalamualaikum everyone. Today's episode is an enrichment lesson on change in entropy. What is the change in entropy of the metal gallium that melts in your hand? Find it out by watching till the end of this video. And the question is, if 25.0 grams of the metal gallium melts in your hand, what is the change in entropy of the gallium in this process? How about the change in entropy of your hand? Is it positive or negative? Is its magnitude greater or less than that of the change in entropy of the gallium? Consider these data. The melting point of gallium, capital T, equals 29.8 degrees Celsius or 302.8 Kelvin. The heat of fusion, L sub F, of gallium equals 8.04 times 10 to the fourth power joules per kilogram, and the temperature of the hand, T sub hand, is equal to 37.0 degrees Celsius or 310 Kelvin. First thing first, let's look at the given data. We have the mass, small m, of the gallium metal equal to 25.0 grams. Its melting point, T sub G, equals 29.8 degrees Celsius or 302.8 Kelvin. We are also given the heat of fusion, capital S sub F, of the metal gallium equal to 8.04 times 10 to the fourth power joules per kilogram. And the temperature of the hand, capital T sub H, equal to 37.0 degrees Celsius or 310 Kelvin. And our target variables are the change in entropy of gallium, that is denoted by delta S sub G, and the change in entropy delta S. This is for the hand. When you put a 25.0 gram mass of a piece of metal gallium in your hand, it will melt because its melting point of 302.8 Kelvin is lower than the temperature of your hand, which is 310 Kelvin. The thermal energy is transferred from your hand to the gallium metal, causing it to melt. And this amount of energy released by the hand is absorbed by the metal gallium. And we use the formula Q equals MLF, where M is the mass of gallium and L sub F is a constant known as the latent heat of fusion of gallium. Okay? And we also use uh, the formula for determining the change in entropy. All right, delta S equals Q over the absolute temperature T. In the case of gallium, since it's going to absorb the energy from the hand, all right, uh, the formula for determining delta S, okay, has a positive sign for Q to emphasize that the energy is being transferred to the system, which is the gallium. All right. So that is the meaning of the positive Q. Energy is being absorbed by the system. In this case, the system is gallium. All right. Now, this process of melting, all right, at its constant temperature is considered a reversible thermodynamic process. All right. Uh, it is reversible because uh, the metal gallium can return to its initial thermodynamic state by releasing the same amount of energy that it absorbed. Right. Now, in the case of the hand, the change in entropy is determined still by the same formula, but as you can see here, the sign of capital Q is negative, all right? Because the hand liberates or gives up that amount of energy, which in turn is absorbed by the metal gallium, all right? And unlike the melting process of gallium, uh, releasing its energy, okay, is considered an irreversible process. Right? This process of liberating energy does not significantly change the internal energy of the hand. Hence, its temperature, all right, which is the normal body temperature, will just stay at 37.0 degrees Celsius or 310 Kelvin. And unlike the melting process occurring in the gallium metal, which we consider as a reversible process, the change in entropy for the hand is considered an irreversible process, which means after liberating energy to gallium, the hand can no longer return to its initial thermodynamic state. All right? When you say initial thermodynamic, the thermodynamic state is before it releases its energy, all right? What is its initial state in terms of uh, the internal energy, all right? Uh, the uh, the temperature, all right? Or probably other quantities, including pressure, all right? So, an irreversible process means that the system can no longer return to its original thermodynamic state, all right, before the process has started. Moving on now to our computation, the energy absorbed by the gallium metal, Q, which is equal to the mass multiplied by the latent heat of fusion, all right, is equal to 2.50 times 10 to the negative 2 power kilogram times the value of the heat of fusion, 8.04 times 10 to the fourth power joules per kilogram. So doing our math, we will get the amount of energy absorbed, capital Q, equal to positive 2.01 times 10 to the third power joules. Again, we are emphasizing that the meaning of the positive sign is that this energy is absorbed by the system, right? Now for the hand, or the change in entropy of the metal gallium, all right, using the formula delta S equals Q over the absolute temperature T, all right, or positive 2.01 times 10 to the third power joules, okay, divided by 302.8 Kelvin. Again, doing our math, we will get the change in entropy of the metal gallium equal to positive 6.64 joules per Kelvin. All right? It is positive as a result of having a positive sign for the big Q. But a positive change in entropy simply means that gallium has increased, all right? It has an increased, uh, it has increased its entropy, or it has gained this amount of entropy equal to 6.64 joules per Kelvin. Likewise, for the hand, we can calculate for the change in entropy, all right, delta S of the hand equals negative 2.01 times 10 to the third power joules divided by 310 Kelvin, all right? The sign for the big Q is negative because the hand liberated or released, all right, that amount of energy. So again, doing our math, we get the change in entropy for the hand equal to negative 6.48 joules per Kelvin, right? So the meaning of the negative change in entropy is that um, the hand, when it releases energy, all right, its entropy is decreased. Or in a way, we can say that the hand loses an amount of entropy equal to 6.48 joules per Kelvin. All right? So, uh, you will notice that the change in entropy for the hand is lower in magnitude compared to that of the gallium metal. All right? So, what does this mean? This means that there is an increase in the net entropy. All right? An increase in the net entropy, which can also be interpreted as an increase in the entropy of the universe. All right? The change in entropy of the hand, all right, has a magnitude less than that of gallium. All right? Since the process of releasing energy by the hand is considered irreversible, and this results to an increase in the net entropy, meaning the delta S for the universe is positive, right? When we say delta S for the universe, that is simply equal to the sum of the delta S for metal gallium plus the delta S for the hand. All right? So if you're going to add the two changes in entropy, for the gallium metal, it is positive 6.64 joules per Kelvin, and for the hand, it is negative 6.48 joules per Kelvin, which gives us the sum of positive 0.16 joules per Kelvin. So to summarize, we say that the metal gallium has gained entropy, while the hand has lost a less amount of entropy compared to what gallium has gained. And this results to an increase in the entropy of the universe by as much as 0.16 joules per Kelvin. And that concludes our tutorial. All right, till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.